Okay, this video is about doing math with sig figs, or what happens if you have a bunch of numbers, you know the sig figs, you've got to do calculations. How are the sig figs going to propagate through the calculation? Okay, sorry for that. Okay, so number one, why should you care? For me, I guess the main reason I care is keeping track of sig figs in your calculations is the easiest way to estimate uncertainty in calculations using your measurements. So every measurement that you take in a physics class or engineering lab or something will have some uncertainty associated with it, right? It's either going to be a 2 sig fig or a 3 sig fig number, and obviously it's harder to get more sig figs. So essentially, the number of sig figs in your measurements should affect the number of sig figs in your calculations. And it turns out it's not obvious. When you're doing multiplication or division, the number of sig figs is kept. And this is the rule that everybody's usually pretty good at. So for example, if I had 2.0 newtons times 3.00 meters, in this case, this number has 2 sig figs. This number has 3 sig figs. I would keep the smaller number of sig figs when you multiply. I like to think of it as keep the crappier number, right? This is the limiting number of sig figs. We can't do better than 2 in this calculation. So in this case, this would be 6.00 Newton meters. And like I said, we keep the smaller number of sig figs, so I would round it right there. You're going to notice me doing this a lot. I very oftentimes will keep an extra digit and underline where it should be rounded. I do this for reasons I'll explain in a minute, but on your test, you would probably write this as then 6.0 Newton meters. Okay, and you may be saying, what the heck is a Newton meter? Whatever, let's worry about that later. It turns out to relate to torque. All right, when you add or subtract, this is the rule people usually forget. Whoops. The column of sig figs is kept. And here's where things get really sneaky. Let's say we had 13.41 seconds, and I'm going to subtract 12.8 seconds. In this case, let's look at the number of sig figs. This one has 4 sig figs. This one has 3 sig figs. Now, just so I don't screw this up, I'm going to punch it in on my calculator real quick. I don't want to think. I'm tired. 13.41 minus 12.8. Oh, I'm still in engineering mode. Let me go back to float. 0.61. Okay. Now, when I'm doing this, I want you to pay attention to something close here. This had 4 sig figs, this has 3 sig figs, but the number of sig figs is not what matters. It's the column. So when I add or subtract, and I have to keep track of sig figs, I go back to this way. And notice I'm very neat in trying to line up the columns perfectly. So here, I could also say this is good to the hundredths. This is good to the tenths. Which one of these is crappier? The tenths column, not because it's 3 sig figs, but because it's only to the tenths column. So in this case, I would actually keep only to the tenths column. How many sig figs? 1. This is very weird to people. And it's not 1 because it's 4 minus 3. It's 1 because it happened to go to the tenths column. What if this was 11.8, right? Then it would be 1.6 and you'd have 2 sig figs. So again, I oftentimes write my answers like this when I'm writing it on paper, and then my final result for this one would equal 0.6 seconds. So again, on paper, I often include both the unrounded and the rounded. All right, so let's take a look at some more of these here. So some extra facts here. I normally keep at least one extra digit on my intermediate answers. If I needed to use this number or this number in a separate calculation to get something else, I would use the unrounded number here to make sure I'm not rounding too early. That's called intermediate rounding. So you typically keep at least one extra digit. One should suffice in almost every case. So keep an extra digit most of the time. If you're worried, keep two. And then you use your unrounded result, but you track where you're supposed to round. And then at the end of all your calculations, you finally do the rounding and put your correct rounded answer in the answer box on the test. Exceptions. There's always exceptions. In general, in an engineering class, they usually ignore sig figs all the time and just say, assume everything has 3 sig figs. Exceptions. If the first digit is a 1, they'll include 4 sig figs. We could talk about percent errors if you are curious, but basically numbers with a 1 that only have 3 sig figs have significantly more percent error than if they use 4 digits. So a lot of times engineers will add an extra digit. Measuring devices in the lab will do this too, like I have DMMs. And for some reason, whenever you have a 1 or a 2 as the first digit, it'll have 4 digits. But if the digits are 3 through 9, it'll only give you 3. So some equipment does this too. In short, keep an extra digit and do this. Maybe we should do some examples, right? So keep extra digits in the intermediate results. And then sometimes people keep an extra digit if the first digit is a 1. If you're not sure about that, talk to me before test day in office hours. Let's look at some examples here. So let's at least do one. All right. And so I'm just going to, I'm going to do problem 1.14. This is in my workbook, volume 1. It's on page 7. All right, the problem's 1.14. So we know that delta x, we're given some weird equation, is 1/2 a sub x t squared. If you've taken a physics class before, you probably know this equation. All right. Furthermore, we're given some measurements. We're told that a sub x was measured in meters per second squared as negative 1.23 times 10 to the 1. V0x was measured in meters per second as 5.85 times 10 to the minus 3. And the time in seconds was recorded as 0.0987. So this is somewhat realistic, where a lot of times you'll have measurements, and you make sure I'm on the right board. I am. It's a little sloppy. Sometimes you get mixed notations, right? Maybe somebody would have written this as 5.85 millimeters per second, right? This one's in scientific as well. This one's not. It's in floating notation, whatever. This happens. You get different notations, sometimes different units. So what are we trying to figure out here? Compute x. All right, so I'm going to assume we're trying to figure out x. Let's go ahead and put in some of these numbers and talk about the sig figs. So it's not just getting the number, it's also getting the sig figs right. Now you might be saying, I could do this all in the calculator, all in my head. You got the units. I like to let the paper do the work. And I think if you get used to that as well, I highly recommend this. Just get the work on the paper. It probably seems like it takes more time, but you oftentimes make fewer mistakes. You get less frustrated. So sometimes it can save you time in the long run. So let's get this in here. This is how you read this. In a typical table, the units are listed next to the variable. And so you have to know this is the number and these are the units. It's done this way so that you can use calculations in your spreadsheet without getting screwed up and having the computer think it's a string instead of just a number. All right. T squared 0. So just to be clear, using pink for this one, or the cyan for that one, and pink for this one. Now, when I do this, I could punch these numbers in pretty quick, and I'm going to do that. I expect you to do that too, so follow along. 0.5, that's a half, times negative 1.23. I'm going to use the EE button. EE, is that 1 or negative 1? It was negative 1. I apologize. In the workbook, this is a negative 1, so this should be a negative 1. I apologize. Check that. Sorry. So I need to do E negative 1. Okay, it's important to learn how to use your calculator. Take the time to follow through and make sure you know how to use the negative button versus the minus sign. Okay, make sure you know how to use the EE button. All right. If you don't, talk to me in office hours. Okay, times 0.0987 x squared. I'm just going to write down this first term so I don't screw it up. Obviously, you could store it in your calculator. You might want to learn that. But in this case, I get negative 0.0005999114. Do I really need all that? What are the units, etc.? Well, let's look. I have meters per second squared times seconds squared. This should be in meters. That's a good sign. Usually delta X is a length in meters. How many sig figs? Let's go. This one has 1, 2, 3. This one has nothing, 1, 2, 3. So this is a 3 sig fig number. This is a 3 sig fig number. How many sig figs are these? At first glance, you might be saying, this is a 1 sig fig, this is a 1 sig fig. But this number is an exact fraction from calculus. And so sometimes you're going to get numbers like this in your formulas, and we assume, unless otherwise specified, like pi, we assume pi has infinite digits, 3.14159, etc. 1/2, or the square root of 2, we're going to assume has infinite digits unless otherwise specified. So this does not limit our sig figs. This is a 3 sig fig number times 3 sig figs times infinite sig figs. We pick the smallest number of sig figs. That's going to be 3. We're doing a multiplication. So now I go over leading zeros, not significant. 1, 2, 3. Right there. That's my sig fig. So that's my rounding column. Now I'm going to add this next one. Going to get my calculator, work it out. 5.85 second EE negative 3 times 0.0987. Okay. What are the units? Meters. What are the sig figs? It says 3 sig fig, 3 sig fig. That means it's a multiplication. We keep the number of sig figs, not the column, the number. We're doing multiplication. 1, 2, 3. So 1, 2, 3. All right. And now you'll notice that I keep these extra digits because they're in my calculator. So normally I would use the stored values in my calculator whenever possible. But if I wanted to, there's no need to keep all these extra digits. What we're saying here is I'm off in this column. That's right. Why keep all that extra crap laying around? Here, I'm off in this column. So I'm going to round that to a 4. All right. Now I don't have to keep as many digits around. In this case, now I want to add these two numbers. I'm adding or subtracting. I worry about the column of sig figs. So I'm going to line this up like old school. I'm going to put the, let's do this. 0. Well, I'll do it this way. Okay, we see these numbers have 3 sig figs, and we're adding this negative to that positive. Now, when I do this, I should be able to just go, I could take this number and add it to going back up a couple of columns, this one. Whoops, I screwed it up. Well, that's why I wrote them down. I apologize, I hit the wrong button. So I'm going to do negative 0.000591 plus 0.00057774. And now I get 0.0000217 meters. Now check this out. We got to keep the column of sig figs, right? 1, 2, 3, 4, 5, 6 columns. So the millionth digit. 1, 2, 3, 4, 5, 6. That's where you round. This had 3 sig figs. This had 3 sig figs. Our final answer should only have 2 sig figs. This happens. I'm going to do it to you on test day to see if you pay attention. All right. Now, why don't we write this in both scientific and engineering notation? That way, when I ask you to write it in one of those notations, you know how to do it. In particular, I think I asked for this in engineering notation. Okay. So let's do it in bold just to get the practice. So 1, 2, 3, 4, 5. So it's 2.17 times 10 to the minus 5th meters in scientific notation, if we needed it that way. Or I could write this as 1, 2, 3. 1, 2, 3. It would be 21.7 times 10 to the minus 6th meters in engineering notation. Then I use my prefix 10 to the minus 6th. Look on the back if you forget. 10 to the minus 6th is micro. So this would be 22 microns. That's like a half of a very fine human hair, maybe somewhere between a half and a tenth of a human hair, depending on how coarse your hair is, if you're curious. All right, so notice we might need to pay attention to this notation when we're doing, this happens all the time, where you take these numbers, you have to get them in your calculator in a bunch of mixed notations, spit out a number, and then write the answer in another notation, usually in this one, because that's where you want to go for prefix. So I hope that gives you a clue. There are other rules for logarithms on sig figs and sines and cosine, but for now, let's just focus on getting addition and subtraction straight. I can tell you more about how to handle logarithms and sines and cosines some other lifetime. All right, let's just focus on the basics. I think that's enough for now. Practice a few of these. You got to get fast at it.